Hello everyone, today we're going to talk about the stereochemistry of the epoxide opening reactions with a base or with an acidic conditions. So as you may know that when the epoxide reacts with the base attacks the less substituted carbon. So let's say this is carbon number 1 of the epoxide and this is number 2. It can attack either 1 or 2, but because it's a base, so it attacks the less substituted. Now, you may already know this. So what's new? The stereochemistry. So what you should know that it attacks from the back side. So our product is gonna be like if it attacks here, this bond is gonna give the electrons to the oxygen, and so this is carbon number 2, this is number 1, number 1 is attached to the O minus, and the CH3 it's gonna be like this because like the stereochemistry of this oxygen, you keep it the same, and the CH3, because it can't be like this like the oxygen, so it goes inside. But what matters to us is the stereochemistry of the carbon number 2. So this hydroxide, which is a strong base, attacked it. So it doesn't attack like this. You always put it trans to the O minus. So you have to put it going inside the board. So this is OH minus, like the hydroxide that attacked. Okay, and after that, you just protonate the O minus. So you just get the same thing. Alright, obviously here you have two hydrogens. So it really doesn't matter if this goes inside or not, because it's not chiral. Because you have here two hydrogens. But what I wanted to explain is that the base always attacks from, like, it always attacks the less substituted carbon, and its position is going to be trans to the OH group. Okay. In the second example, we have an acidic condition. So if you have an acidic condition, obviously it's going to be a weak nucleophile because you don't have a strong base. Usually it's an alcohol, and it attacks the more substituted carbon number 1. Okay, so this is carbon number 2, this is number 1, and it leaves here this time. So if it attacks carbon number 1, the oxygen, like the epoxide, is going to open to the left side. So it's going to be, as we said, you don't change the position, the stereochemistry of the leaving group. Obviously it's going to be OH at the end. And again, this is not chiral, so it doesn't matter really. And on the other side, the OR attacked. So you just put this group at the more substituted carbon. But it also attacks from the backside, so it's going to be trans to the OH, so it's going to be like this, going inside. So no matter if it's in a basic condition or an acidic condition, it's going to be trans to the OH group. Okay, and obviously we have another hydrogen. Okay, let's do the last example. So we have water, weak nucleophile in acidic condition. So the water in this case is gonna attack the more substituted carbon because it's more substituted and it's in an acidic condition. So in acidic condition, the weak nucleophile attacks the more substituted carbon. So it's gonna open like this. Let's just draw it. In the same way it's drawn. So like this. It left to the bottom side. We don't change the stereochemistry of the leaving group, but the nucleophile is going to be trans to it. So it's going to be in an acidic condition, always the nucleophile is, because it's weak, so it's going to lose a hydrogen at the end. So let's say if we had water attacking, it's going to be OH in the final product. If we had an alcohol, CH3OH, it's going to be OCH3, so it always loses a proton at the end. So it becomes neutral and not positive. So again, no matter if it's an acidic condition or a basic condition, always the OH and the nucleophile is trans to each other. Trans. And here it's trans also. So the difference between an acidic condition and a basic condition is that in a basic condition, it attacks the less substituted carbon in the epoxide. Okay, that's it about the stereochemistry of this reaction. If you have any questions, always feel free to add me and message me on Skype. It's in the description below. I wish you good luck. Good day.